what I need to be able to reject this is evidence that this is true. Right? I essentially need evidence that the alternative is true, and I need evidence that is far enough into the alternative, or strong enough for the alternative, to say that the alternative must be true and that the null must be false. Is a value of 0.3 evidence for p being less than 0.2? No, it's greater than 0.2. So it's certainly not evidence for the alternative in any way. What will actually happen is if we calculate p-values, what we will find is that the p-value will be something greater than 0.5, and we're clearly not going to reject the null hypothesis. Okay? And if you had seen something like this and stopped at this point and said fail to reject the null, that's acceptable, unless I actually tell you to calculate the z-statistic and stuff like that, which is what they told us here. So in this case, we're looking for p greater than 0.2. So our z-statistic then is what? Should be 0.3 minus 0.2. So is our z going to be positive or negative? 0.2, 1 minus 0.2 over 500. What's going to happen to this? I have a large n in my denominator here. The large n in the denominator of this is going to make this value here what? Small. A small denominator in z is going to make the overall value of z what? Relatively large, yes. And it depends on how large the numerator is. This one comes out at 5.59. Okay. And quickly, d, n is equal to, was it 200? P hat is what? 0.5. Null is p is equal to what? 0.8. Alternative is that p is less than 0.8. Okay. Our z is equal to 0.5 minus 0.8 divided by 0.8. 1 minus 0.8 divided by 200. So that's a negative value. And I think that comes out to minus 10.61. Okay? So let's calculate p-values. For each of these, what you should do for p-values is start by drawing the picture. Put 0 in the center. I have 1.10 here. So I'm going to mark off my 3 divisions. 1.10 occurs about here. Do I need left tail, right tail, or both tails for this? The p-value is the probability that we are at least this far or farther away from the null hypothesis into the alternative. And our rule should be that the tail we use is the direction that the not equal sign points. So less than points to the left, that should be a left tail. The greater than points to the right, that should be a right tail. The not equals actually points in both directions, and so it should be both tails. We want there, and we also want to the left of minus 1.10. Okay? From our rule, what we're going to do is take the p-value is equal to 2 times a.1, and we want minus the absolute value of z, so that means minus 1.1. Effectively, what I've just said is I want to use the table to look up the area to the left of this negative value right here. And since these two areas have to be equal, twice whatever this is will give me my p-value. 2 times, what's table 8.1 for minus 1.10?
0.1357.
Okay. So that says our p-value is something like 2.7 something. I'm not sure what the rest of it is yet. So. And it's not too important, is it? Would I reject the null hypothesis here? This says that there's roughly a 27% chance that I would see something like this if in fact the null hypothesis were true. That says roughly 1 out of 3 times I'm liable to see this. So that's fairly likely. So I'm not going to reject the null hypothesis. This case here. And I'll go faster here. This is minus 2.68. So minus 2.68 is right here. This is a less than condition, so I want the left side here. So what I want is 1 minus whatever 8.1 says for minus 2.68. And that is going to be equal to 0.0037. So that says that there is less than a 0.4% chance that this would happen if this were true. So what must be true about that? It must be false. This implies that we reject the null hypothesis because the observation is quite unlikely. Okay. This case here, so 5.59 is out here someplace. In order to come up with this, I need 1 minus, did I do this correct? I didn't, did I? That shouldn't be 1 minus, should it?
2 times.
Nope, just 1 time. 2 times for both tails are not equals condition. Just 1 time for this. And nobody caught me. You should correct me. Okay, this case here, this is a 1 minus. Because this is a greater than condition here. So this is 1 minus 8.1 of 5.59. You'll need to go down to the bottom of the table because the table values only go up to 3.5. If you go down to the bottom of the table, there are extreme values, and essentially it's adding bunches of 9s. And this is 1 minus 0.1, 2, 3, 4, 5, 6, 7. These things. Okay? So this is essentially 0. So that says that if this is true, it's essentially impossible for that to happen. So we're going to reject that. In this case here at minus 10.61, what do you think is going to happen? Do you think you're going to reject the null hypothesis here? You shouldn't have to think very hard about that. Okay? This is way off the end of the table. Essentially, the p-value in this case is 0. This is essentially impossible if that were true. The end result of that is that you are going to reject the null hypothesis. Okay, on Friday, we'll pick up with, at the beginning of class, working with true proportions, and we'll work through some of that.